All right, so feel free to participate in the chat during this little review session, or I guess we could say a new unit. So when you think of a square, that's two-dimensional, right? When you think of a cube, that's three-dimensional, right? So I'm concerned with squares right now, which is two-dimensional. And the way you find the area of a square is you multiply the side by its side. Or you could just square the side, and you would find the area on the inside. So let's say that this square had a side length of 4. And if you wanted to find the area, you would multiply 4 times 4, which is 16. The area would be 16. The square root of 16 would be 4. Because the root of this square, if I were to make a square out of 16, and I were to be given the area, that means that the side length would have to be 4 on all 4 sides. So the square root, this symbol means the square root of 16 would be equal to 4. How do you guys feel about that so far? So if I asked you what the square root of 5 was, the square root of, I already told you the answer for that. What is the square root of 36? If I were to ask you, what is the square root of 36? What would you respond? Imagine a square with the area of 36. What is the side length of that square? Can you guys tell me in the chat? In the chat? Well, I got 2 responses and they're both wrong. So let me remind you of a few things. 1 times 1 is 1. Okay? 2 times 2 is 4. 3 times 3, you guys know that, is 9. 4 times 4 is 16. 5 times 5 is what? Thank you, 25. 6 times 6, go ahead and type it in the chat for me. 7 times 7, 49. 8 times 8 is 64. 9 times 9, 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169. 14 times 14. I always remember 14 times 14 and 13 times 13 because it's like the 6 and the 9 get flipped. 196. Do you see the pattern in 13 times 13 and 14 times 14? That's how you remember those. And then 15 times 15 is somewhat easy to remember. It's just 225. And then my favorite multiplication is 25 times 25, which is 625. Okay, so now that I reminded you of when a number is multiplied by itself, like a square, another way to write 1 times 1 is 1 squared. Another way to write 2 times 2 is 2 squared. Another way to write 3 times 3, that's 3 squared. 4 squared. 5 squared. 6 squared. 7 squared. 8 squared. 9 squared. 10 squared. 11 squared. 12 squared. And I know that this is a lot of writing. You don't have to necessarily write this down, but I think it'll help you when you guys start working more with perfect squares. So I want you to remember the geometry behind this. And the geometry is simple. It's just imagine a square with a side length of 1 by 1. This is why we call a 2 at the top of a base. This is the base, this is the exponent. When you have a 2 as the exponent, that means square. Whenever you have a 3, that means cubed, like 3-dimensional. But we're not concerned with 3 dimensions right now. We're not concerned with the 3 as an exponent. We're concerned with a square as the exponent, the 2 as the exponent. So imagine a square with side lengths 2, side lengths 3, side lengths 4, side lengths 5, side lengths 6, side lengths 7, blah, 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 blah. This square root symbol is asking you what's the side length of a square with an area of 36. So let's look at 36. The square root of 36 would have to be 6 times 6. Another way to write this is the square root of 6 times 6. Whenever you have a pair or a square or a set of numbers inside of a square root symbol, Okay, let me backtrack just a tiny bit. What is the opposite, or what is the inverse operation of multiplication? What's the opposite of multiplying? The inverse operation of multiplication is division. Those are inverses of each other, right? What is the inverse operation of addition? If you want to undo addition, you would subtract. Okay, now here's another set of operations for you. There's another set of operations. There's the square root, and then there's squaring a number. So the opposite of squaring a number is square rooting the number. And the opposite of square root is squaring. So inside of this square root, you have a square. You have 6 times 6. Another way to write it is like this. 6 squared. This square, this 2, undoes the square root. This square undoes the square root. So you're left with 6 as your answer. So I'm going to ask you another question. What is the square root of 49? The square root of 49. So imagine a square with an area of 49. What is the side? What does the side have to be? Yep, 7. What is the square root of 64? Eight. So now let's write another pattern. This is going to be our other pattern. Well, the square root of 1, that's just 1 times 1, which is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. Whoop, sorry guys. The square root of 49 is what? Seven. The square root of 64 is what? We already discussed this. 8. The square root of 81 is 9. The square root of 100. The square root of 100 is 10 times 10, which is, so it's not 50 times 2, it's 10. Square root of 100 is 10. What's the square root of 121? Square root of 121 is 11. What's the square root of 144? 12. Square root of 169 13. 196. 14. Square root of 225. 15. Square root of 625. 25.